Whoa, jeez! You scared me there. I didn't see you sneak up on me. Well, you're just in time. It's 4.4b, solving linear equations by graphing. Alrighty. So what we're looking at today is basically this idea where you have an equation with, I don't know, say like 2x plus 3 equals 4x minus 5. And we could solve, and we could get all the like terms on one side and all the numbers on the other side, and we could solve it for x. But what I want to do is instead solve this using graphing. All right, and in order to do that, I basically want to treat the left side of the equation like it's its own equation and its own graph, and the right side of the equation like it's its own graph. So this side, the 2x plus 3, would really look more like y equals 2x plus 3, and I could graph that. And then I would take the right side, this 4x minus 5, and it would really be like y equals 4x minus 5. And I could graph that, and where they intersect, the xy coordinate point, that's my solution. So we're going to look at how we can do that instead of doing it out algebraically. So the example that I have for you, let's do blue for the first one, is x minus 2 equals negative 1 half x plus 1. So the left side of the equation I'm going to use in blue. I'm going to think of that like y equals x minus 2. And the right side of the equation I'll do in red right here. I'm going to think of that as y equals negative 1 half x plus 1. And then I'm just going to graph each one separately. Get my coordinate plane set up here. Get my x and my y axis. And now I can worry about plotting my points. I'm going to do the red one first. My y-intercept is 1. And then I have a slope of negative 1 over 2. And that means up 1 over 2, but in the negative fashion. So down 1 and over 2. And down 1 and over 2. And I can do the same thing in the other direction. And now I'll do my blue. My y-intercept is negative 2, so that's down here. And my x value, my slope value is 1. So I'm going 1, I'm going 1. That looks like an important point. 1, 1. And now let's get my arrows going. Here's my line for the red one, and here's my line for the blue one, and I've officially graphed them. And what is super, super, super cool here is this nice little intersection right there. Boom. That is my solution. And it's at x equals 1, 2. X equals 2 right there. The full coordinate point is 2, 0. And that would be my solution if this was a system of equations. But the x value is what's really important there to make this equation true. Let's take a look at how that works. If I plugged it in, I would have my original equation, x minus 2 equals negative 1 half x plus 1. And I plug in my value that I'm saying is a solution. 2 minus 2 equals negative 1 half times 2 plus 1. Negative 1 half times 2, that's negative 1 plus 1 over there, equals 2 minus 2. 2 minus 2 is 0. Negative 1 plus 1 is 0. 0 equals 0. That's absolutely true. So my solution works. Cool. And that is how we solve an equation like we normally would do analytically and algebraically by combining like terms. That's how we solve it using graphing. Alright, that's all that I have for you this time. So do the assigned problems and write down any questions. I'll see you guys in class.